In this question, we are given that a fighter plane flying horizontally with the speed 360 km per hour at an altitude of 500 meter drops a bomb for a target. Straight ahead of it on the ground, the bomb should be dropped at what approximate distance ahead of the target? Assume that acceleration due to gravity is 10 meter per second square. Also neglect air drag. So in this question, we are given that we have a fighter plane and the plane is flying horizontally. So let it be a plane, let it be a fighter plane. So let it be a plane. The plane is flying horizontally with the speed 360 kilometer per hour. That is 360 into 5 by 18 meter per second. So if we do it, then it becomes 1825 to 100 meter per second. So horizontally it is flying with 100 meter per second, and given that at an altitude of 500 meters, so altitude is 500 meter here given, drops a bomb for a target straight ahead of it on the ground. Drops a bomb for a target. It drops a bomb from the plane for a target straight ahead of it on the ground. The bomb should be dropped at what approximate distance ahead of the target? We need to find the approximate distance from the target at which the bomb must be dropped, so that the bomb should be okay. Assume that acceleration due to gravity, so a is minus 10 meter per second square. That is, the value of acceleration due to gravity is given us as 10 meter per second square, and the distance it has to cover is minus 500 meters. So let it be like it. So we know the value, we know the formula of time, so even we can calculate. So you can see that when we see it about just y-axis, when we see it falling vertically, then initially it was dropped from the plane, so its u becomes 0. When you talk about the vertical motion, its s means that is the total distance it has to cover is 500 meter, and acceleration due to gravity, that is the acceleration is 10 meter per second square. So from this we can get the value of time. So s is 500 is equal to u into t, 0 into t, that is 0 plus half into a into t square. So 2 5s are 10. So t is equal to 10. So t becomes here 10 seconds. 10 seconds. So from it we get the value of t is 10 seconds, because see 5 will cancel it with 100. I mean 500 is 500, so it becomes 10. So time here becomes 10 seconds. And now see one thing, that the time that if it falls directly, that is the vertical motion, if it completely follows vertical motion, then it will take 10 seconds. So we need to, you can imagine it as a projectile motion that is happening from a height, that has not started from the ground, but it's happening from a height. You can imagine it like this, projectile motion from a height. So we have got the time period, and so now it probably we need to calculate the range for this motion. Range here it's like x. So for it you can see that, we know that, you see, when the bomb will fly like this, as we release the bomb from the aeroplane, then it will fly in this manner, and it will drop on him. So you can see it has a horizontal component and a vertical component, but there is no other force that can affect its horizontal component. And even here you can see that we have to neglect the air drag, so there is no horizontal force that can cancel out or that can affect its horizontal motion, and the gravity is affecting its vertical motion. So from this phase what we can do is, we know distance. Here the distance we have taken as x. Distance is equal to speed into time. Distance is equal to speed here is given is 100 meter per second. 100 into time is here 10 seconds. So the distance here becomes 1000 meter, that is 1 kilometer, or 1000 meter. Okay, so option number a given us 1000 meters, so it becomes the correct option.